because there's no real way of doing it. And I wasn't even sure if it made sense to do that.
Okay, let's have a look first. I'll quickly show you how do we do clustering, in R, right? So we've got both R and SPSS open. So I'll quickly launch Rattle. If you want to follow me, you can try and follow me on your own systems as well. Siddharth, you managed to get Rattle working?
Yeah, Karan.
How did you get it working? You had a GTK problem, right?
Yeah, I got it fixed.
Okay, excellent. Alright, so let me just import the same data set. It's a telecom exercise. I execute this. Import. Now in clustering, I am not doing any predictive modeling, so I don't need to partition the data set. Alright, and I'm going to ignore the categorical variables for now. Median education, the missings as well. I don't want the missing variables. Start and churn. Execute. Before I do the clustering, I just want to transform the variables. Alright, so why would I want to transform the variables?
They have to be standardized before you can cluster them.
Correct. All of these variables are on different scales, right, Kiran? So in the transform tab in Rattle, there's an option called recenter. It says rescale so that mean is 0, standard deviation is 1, which is the same as standardization, right, Kiran? Hello?
Yes. Yeah.
Alright. Yeah, so I can just select all the variables and unselect the variables which I don't want. The rescale. And I press execute. Right? I go back to the data tab. I see all the original variables have been ignored, and we've created the rescale variables that we can use for our cluster analysis. Alright, what I can do is I can go to the cluster tab now, and we've got the options k-means clustering, the other other kinds of algorithms, but I've got hierarchical clustering over here, right? In hierarchical clustering, it gives me an option what kind of distance criteria I want to use. So obviously we go by the Euclidean distance, which is the most commonly used formula. So the Euclidean distance is the one where we use the delta x square plus delta y square under the root, right? And within the method, right? So which method do we want to use? The nearest method, the farthest method, the centroid method, right? So we're going to go by the Ward's method itself, right? I press execute over here, right? Now what it's going to do is it's going to open up the option that how many of the clusters do I want. So if you remember, right, Siddharth, if you remember in SAS, it was a two-step process, right? We first do a proc cluster and then we do a proc tree, right?
Yeah.
So
Yes.
what does proc cluster do?
It starts from a number of data points, that many number of clusters, and then one set.
Correct, right? And the proc tree option we give how many clusters we want. So over here as well, we've run the first option or the first criteria on hierarchical clustering, so it's clustered everything. After that, I can generate the dendrogram, right? It says how many clusters and then the dendrogram. So I click on the dendrogram over here, right? And I'm going to execute that. First is asking me to install a package, right? So I'll quickly download and install this package and then run the dendrogram. All of you please try it out. There are some dependencies, so let it be. And here we have a dendrogram, right? So Siddharth, can you quickly explain this dendrogram to me? What do
Yeah,
we mean by
so
this dendrogram?
at the base, we are starting with number of data points, that many clusters,
Yeah.
and as we move a level up, it's the data points which are getting combined into different clusters, and height should be the relative R square, which is the difference between different steps.
Right. So height is the again in SAS we get the relative R square, the semi-partial R square. So the y-axis is a function of the distance at which the clusters are combining together. Right. In the
Okay.
beginning,
Yeah.
obviously our points are very close to each other. The smallest point gets collapsed first. Right,
Yes.
Siddharth?
Yes, correct.
Right. So as I keep doing clustering, then clusters which are further and further apart start combining together. Right.
Yeah.
Right. So in the beginning, so when I started the Rattle, I gave a dendrogram with number of clusters equal to 10. Supposing I want to, remove it and I say I want to do it with 4 clusters. I click it again, I get the same dendrogram, except now it's been resized to 4 clusters. So let it come out. Just a minute. Run it again. Here we go. Right,
Yeah.
Siddharth? So if I
Yeah.
go, so this red line is intersecting the dendrogram at 4 points.
Yeah.
Right? So these red boxes are the 4 clusters that I'm going in for. If I go in for 3 clusters, right, I'll get a slightly different graph. So typically, whichever is the number of clusters I want to go in for, it will show me that way.
Yeah.
Alright, the dendrogram remains the same. Right? Now if I want to get the data set out with my clusters, what I'll go is I'll just simply go to the evaluate tab. I'll generate a CSV file and I want to say where do I want to save it. Let's say I want to save it on the desktop, right? And it's asking me whether I want to include the identifiers or whether I want to include all the variables. So I'll say I include all the variables, the training data set, because it's all training. Sorry, if I have to click training, I have to click all, I will press execute. Now it will ask me where do you want to store it. So now I say I want to store it on the desktop. And I click save, right? So a file will be generated on the desktop. I open that file up. So let it open. Right? So this is my original data set, and in the end, I should get the cluster variable. So these are the standardized variables which were created, right, Kiran?
Mm-hmm.
And then finally, I get H cluster, and these are the 4
Right.
clusters which I have, or the 3 clusters which I have created in my final data set. All right.
Yep.
All right. How many, Kiran? You've got R installed.
Yep.
All right. Let's try this exercise. Can you share your screen? So let's go through a simple exercise. Do a hierarchical cluster on the same data set. Let's extract 4 clusters and do it only on a few variables, 4 or 5 variables. Library Rattle and then Rattle. Yes, yes, yes. Keep clicking yes everywhere.
It doesn't work on that. Yeah, that particular package never installs. It just keeps asking me, and then
Okay.
just and anyway. Do you know telecom?
Yeah, telecom looks fine. Execute. Click execute, not this one. Click execute. Oh, alright, you have to click it on the C. Press no way. Yeah,
This
here.
one, yeah.
You have to click over here. So in case you have Linux machines, then you can install R and Rattle directly. They work better in Linux rather than Windows. So
Yeah.
if in future you want to execute some project and you're not able to install Rattle on a Windows machine, just make it a dual boot machine with Ubuntu and run it
Yeah.
on the Linux over there. Alright, so Kiran, unclick the partition option. We don't want to partition the dataset. I'm going to cluster the whole and press execute here. Yeah, I mean, unclick those variables which you don't want to use for the analysis. Are you comfortable doing regression, logistic regressions on Rattle now, Kiran?
Yeah, model, linear, go that way, right?
Yeah, age we can leave it in, right? Why do you want to ignore age? Let age be there for clustering. Region, education,
Tenure.
Cascade, education, and Cascade and churn in the end, and those missing variables also. So if you look at this in the data reports, scroll down. Yeah. Cascade and churn as well. Now press execute. No, you've already replaced them by 0, so you don't need to do that. Otherwise, in the comment, it will show how many observations are missing in the data set. Alright, execute this. Okay, let's go to the transform tab. Transform. First, standardize the variables, right?
Oh, yeah.
Remember, standardization is a hard requirement. Press Ctrl A. Use Control.
So
That's press execute.
recenter.
No. Rescale is fine. Rescale is okay. Yeah. Recenter. Yeah, correct.
Normalize.
Yeah, press execute. Right. So go to the data tab. You should get the new variables visible over there. Yeah. So the original variables have been classified as ignore, and the new variables have been put as input. Alright. Now
Okay.
go to the cluster tab. If you're running clustering for the first time, it will ask you to install packages. So I'm going to do hierarchical first. Click on hierarchical and Euclidean and Ward.
Euclidean and
So
Ward.
typically anywhere you do clustering, using hierarchical, Euclidean and Ward's minimum variance is the kind of default setting anywhere. Press execute. Yeah, press yes. Let's install the package. Use a US mirror. So whichever state you are in. Yeah, go to Rattle, it should get the result for you over there. The Rattle window. Alright, it's done. Generate the dendrogram. Let's have a look. Let's say you want to go in for 4 clusters. Yes. Press R on the R window. There you get your dendrogram. Alright. Let's say you want to finalize it at the 4 clusters. You can actually save this. So if you go to file, go to the file on the graph, click on file, on the graph, yeah, and you can save it as a PDF file, as a bitmap file. If you maximize the graph, there's an option to save it as actually a PDF. So click on save button.
Save as PDF.
Save as PDF. So you can save your ROC curves, lift charts, all of it as a PDF file, so which you can share it with other people. Alright, let's go back to Rattle. and press execute here now once more, because we are finalizing that we want the 4 clusters. Right now go to evaluate. Right, score option is already there. The data set is all training. In the include option, change it from identifies to all, so it will copy all the variables in your final file. Press execute.
CSV file.
No, just press execute. Now it will ask you where do you want to save it. So save it wherever you want to. Alright, so it's saved on your desktop. Now go to the data tab. Yeah, you just have a look at it. It's on your desktop. No, yeah, just double click it. Scroll to the extreme right. Each observation has been classified to one of the 4 clusters. Yeah. Now close this file in Excel. Close it. Yeah. Now go to Rattle and import the scored file into the Rattle system. Yeah, go to data. Import this new file. Press execute. Press yeah. Alright. Now I want you to make the final variable as your target variable. That's your cluster variables target. Unclick the partition. We don't want the partition. Unclick the partition. Yeah. Press execute. Alright. For all the variables now make it ignore. Except for age. So we are going to test age. Make all the other variables as ignore. So no, you'll have to
You
do
do
it.
it in one shot.
Yeah, it won't happen.
One at a time.
Yeah. Make every variable except age as ignore. Except age.
These are RRC as well.
Yeah, ignore it.
The transformed age.
Yeah, we'll work with the original variables now. So ignore all of them. Those were used only for creating the clusters. We're going to do the interpretation on the original variables. Yeah, press execute. Yeah, go to the test option over there. Go to explore. First, let's go to explore. So I'll show you how to do it. All right, click on distributions. All right, let's check the box plot against age. Click on age, box plot. Yeah, press execute. Yeah, check it out. The other R window. Yeah, maximize, minimize it. The one in the inside one. Click on the maximum minimize button inside. Yeah. Close this. Yeah, close it. This graph. Close this graph and close this graph as well. Just run it again. So it's a bug in R. So graphics found. Just run it again. Press execute once more. All right. Now press yes. All right, Siddharth, if you're looking at this graph, can you explain this graph to me? So this is a box and whiskers graph. Can you explain this?
Yeah. basically showing the age, the range of age in each cluster.
It is showing the range of age. So let's look at the leftmost, the red one, in which the legend says it's all. Alright, so this shows the complete age distribution, right? The topmost and the bottommost lines, they show the maximum and minimum observations in age, right? The center shows the 50th percentile, so the median age is just around 40. Right, Kiran?
Yeah.
Right? And the edges of the red box show the 25th and the 75th percentile. Got it?
No.
Right? So this shows that where is the middle of the variable lying and where is the most of the chunk of the observations lying. Right? Then for it, then it shows the age distribution for cluster 1, cluster 2, cluster 3, and cluster 4 separately. So Kiran, is the age profile of each of the clusters statistically significantly different?
Will be able to test it out.
Visually?
Visually, there's definitely quite a bit of separation. So
it looks quite significantly different from each other, right?
Yeah.
Right. So this is how I can graphically plot and say, cluster 1 has people which are significant, cluster 1 and cluster 2. So out of which cluster 1 is the people who are significantly older, cluster 3 are people who are significantly younger, right?
Yeah.
Cluster 2 and cluster 4 are people which have a moderate age distribution just above and below the median distribution. Right? So I can start profiling the cluster and say cluster 1 is oldies, are primarily oldies who are buying or who are indulging in a certain kind of behavior. Cluster 3 are mainly young and urban people who would probably, go in for a certain kind of distribution or a certain kind of product offering, and so on and so forth. So you need to weave a story around the cluster analysis like that. Can you check the tenure around the clusters, Kiran? Check the distribution of tenure. Unclick age. Yeah, Siddharth, you have a question? Go ahead.
Yes. Karan, are these type of graphs available?
Could you repeat that? Hello. Hello. Yeah,
Karan,
yeah, got disconnected. So could you repeat your question again, Siddharth?
These, dendrograms and this graph, is this available in SAS?
Dendrogram, we generated it yesterday, right? If you remember.
Yeah.
Right. So these graphs are available, but they don't look as nice, and you really have to do a lot of coding.
Okay.
All right. So you can actually just Google the code for box and whiskers in SAS. So you'll have proc gplot, model plot tenure into h class slash box whisker, something like that.
Yeah.
Right. So you can, for example, I showed you how to plot a normal distribution or a histogram as well, right? If you remember.
Yeah.
Right. So there is a procedure called proc gplot. Right. So you can make a note of it, gplot. Right?
Okay.
So proc gplot can be used to generate a whole lot of plots and graphs, but typically if you want to do this, do it on R.
Okay.
Okay. So because over there it will come using graphics which are belong to the era of 80s or 90s. It's going to come out in a monochrome format. They're going to look very ugly.
Okay. Yeah.
Okay. So try and avoid graphing in SAS. So SAS is great for doing the other stuff, but for more data visualization, it's still got a long way to go. All right. So now, Kiran, what you will observe is tenure is looking very similar to age. Do you have any reason why?
Yes. Well, I guess with age, how long they stay with a particular account, with a company varies, right?
Yeah, we know that age and tenure is highly correlated in this
Highly
particular data
correlated.
set,
Yeah.
right? So therefore,
Okay.
even the tenure distribution will tend to follow the age distribution, right? So now I can say about cluster one are older people who have been with the company for a long time,
Longer time. Yeah.
longer, statistically significantly longer than the average tenure of the customer, right?
Mm.
If the average tenure is about 32 months or 33 months, people in cluster 1 have an average tenure of over 55 months. And they are also by age the oldest cluster, right? And the converse is true about cluster 3. So I want to target people for attrition management. Which cluster should I target?
3
Loyalty,
lowest.
right? Loyalty programs should be targeted at, and cluster 1 maybe, attention or retention management should be targeted at cluster 3, right? A different kind of product offerings for cluster 2 and cluster 4. All right. Now, Kiran, I have a question, right? How do I test whether tenure is statistically significantly different across the clusters or not? By looking at this, the averages or the mean values are very different, right? In this case, though, we're
Right.
looking at the median value, but is it statistically significant at alpha level of 0.05? How do we check it?
Tenure is a continuous variable, right?
Yeah,
So
and H class is a
should be.
categoric variable. So can I do a proc ROVA, class H class
Yeah.
model, tenure equal to H class,
Yes.
right? So that's how you
I
would
did that yesterday with factor 1 to 8
on which particular variable. Oh, on the cluster variable. You would see
on
almost
the
all the
cluster
factors
variable.
would
So
come statistically significantly different,
yeah, so it didn't. So that's why I was confused whether
right?
that even made sense.
So,
But
so what will happen is if you're going for an arbitrary large number of clusters, maybe 10 or 15 or 20 clusters, then it will start coming, insignificant.
okay.
All right, or if you use a large number of variables.
Yeah. I mean, yeah, I had factorized the telecom set, and then I used the
Yeah.
cluster as the class and the
Yeah, so
factor
that's
as the variables.
so typically, we won't use ANOVA because ANOVA is difficult to explain, but this box and whiskers is much easier to explain. So if you've done it all 4 or 5 variables, generate the box and whiskers for all 4 or 5, position them next to each other, and then do the what I would say is build the story
Usually,
around the clusters, right?
okay.
So
The SAS actually automatically creates the box and whiskers
which
for
one?
that. SAS, it actually creates the box plot.
SAS, I'm not aware whether it does that.
Oh, it does. I'll show you my code. That's what I was saying. Anyway, well, let's finish this, then I'll show you my series. Like when you do the ANOVA on this variables on cluster,
Yeah.
it'll automatically generate the box plots as well.
You must be using some option. Let me check. Show me the code.
Yeah, I was using ODS graphics on.
Okay. Show me the code.
Open
You can show me the code. Just scroll down. Let me have a look at the code.
Code is just ANOVA. That's for sure.
That's strange. I don't remember. Yeah, maybe. It's been quite a while since I've worked on SAS. Let's scroll down.
Okay. Using some history call here. With this one,
Just run this. I
Do
guess you'll
run
have to run the previous ones as well. Okay, what you can do is just mail the code across to everybody so we can, the others can also have a look at it. Alright, so one more thing that I wanted to show in Rattle was, Kiran, can you just go back to Rattle?
Yeah.
And go to the data tab. And in fact, what I'm going to ask you to do is, can you open the telecom data set in Excel?
Telecom data set in Excel.
Yeah. And physically, just open telecom.csv. Yeah, open that up. Yeah, go to the last extreme right hand side. Yeah, create a variable split. And generate a random number here equal to rand. Yeah, open close. No, don't put a number in it. Yeah, scroll it all the way down. Control C, paste values. No, on top of it. You can do it on top of it itself. Yeah, have all the observations been converted into values? You just click anywhere. Click anywhere.
Yeah.
You just click anywhere. So I want to look at the formula. Here, click on it. Click on AQ, AQ4.
AQ.
Yeah. So yeah. All right. Now just run a filter. Yeah. Let's select number filters. Click on number filter. Go to number filter. Yeah. On top, number filter. There's an option called number filter.
Yeah.
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 Let's say less than or equal to 0.7. Just click 0.7. Press OK. Yeah, do a control A, control C. Now wait a minute, you've run this filter only on that. Just remove that filter. Clear that filter.
No, we do.
Go to data. Yeah, go to the go to data now. There's a data tab on
This
top.
is the data tab.
No, the Excel tab.
Oh, yeah. Sorry.
Yeah, now click the filter over here. So I get the filters on all the variables.
On all of them.
Now go and select only on 0.7 over there.
It's funny why the two different filters work differently.
Because it had filtered only on that variable. I want to filter the whole data set now. Yeah, press OK. All right, now
Yep.
Control A, Control C. Press Control A.
Yeah, I did that.
Now create a new file. I want you to create a new file. Yeah, paste it, call it training, and create another file, call it validation. Save it as a CSV file. Save it as CSV. Yeah. And you can select greater than 0.7 and save it as a validation. Yeah, close this, close training.csv. We don't need it anymore. Close it. So this is training.csv. Yeah.
Yeah.
And now the reverse filter, greater than 0.7. Press OK. And then Control A, Control C, new file. And call it validation. All right, close
Okay.
it. All right. So what I'm now, so close all the Excel files. So we don't want them open. Now what I'm going to demonstrate is, if you remember, in SAS I showed you how to score off, files which are outside the system, right? Right. So that
Score outside the system.
means the score files which are not part of the proc logistic.
Oh yeah. Yeah.
Right. So Siddharth, supposing I build, my model, but I want to deploy that model, even tomorrow. So I can't, create the model again tomorrow, right? So what I'm
Yeah.
going to do is I'm going to show you how to save models in R, right? So you can actually save your model as a file, and the next day open the model again and score off a new file that you received, right? So that's all right. So that sorry, Kiran, you don't need to do that. Just go to Rattle
Yep.
and import the telecom training file. Import training. Press open. Press execute. Make region as input, region as ignore, education as ignore, region education cost cat you can ignore for now. Churn as your target variable, and ignore split because split is not a variable to be used, right? And uncheck partition, we're going to use the whole data set to create the model. Press execute. All right, create a logistic model. Yeah, press execute. All right, test out how good or bad this model is. Generate the ROC for this. ROC. Yeah. So good, bad, ugly, Kiran.
0.82 is pretty good.
Very good. Let's have a look at the shape.
Still coming.
It will be in the R window. That's a pretty good model, right? Now close. Now go to Rattle.
Yeah.
Go to Rattle. Close all the graphs. Go to Rattle. Supposing you've done all the legwork and you've created the model. Now click on save. There's an option called save over there on top, right? And say this is my telecom logistic. Give it a name. Let's say telecom logistic. Dot let it be the name. Let it be dot Rattle telecom underscore logistic. Right? Click save, and you can now close Rattle. Yes. Right? Now you've got the validation data set and you want to apply that model that you created, in your previous session on your validation data set and generate a score against each. You got
Right.
the problem now?
Yeah.
Right? So how do you apply a model that you've already created onto a new data set?
Yeah.
Siddharth, are you clear what needs to be done?
Yeah.
Right? So launch Rattle again, Kiran. Now instead of importing a file, just click on open. No, don't click on the file, open, and open the Rattle file. There it is, telecom.class. Press open. You don't need to do anything. The whole model will automatically open up. Now you don't need to build a model. Go to evaluate option, right? Click on linear. So that's the model, and click on the option called score on the extreme right hand side, right? You remember we did the score option, score output out in SAS, right?
Yeah.
Yeah.
Right. So now it's asking you what do you want to score? You want to score your training data set, right? You say all right. Click on training. Right. So, but the training data set, I already know what's what, right? I want to score some other data set. So click on the CSV option. Yeah. Point to the file. Right. And so what it says is now press execute. So before you do that, just have a look. Include option. What does it say?
Include identifiers
Identifiers
and
or
all.
all, right? So if you click on identifiers, only the ID variable and the probability score will be generated against it,
Yeah.
right? So you want all the variables, let it be all. Now report is there are two options, class and probability, right? Hover over class, right? And hover over probability on the other hand, right? So what is the difference between the two? So if you click on class, it's going to take 0.5 as the cutoff and it's going to generate whether it's a churn or a no churn, right? But if you click on probability, it's going to give you the actual probability score. So which one do we want, Kiran?
We want actual probability, so we can then later on.
So you can later on make your own cutoffs. You don't want to use 0.5 as the cutoff. You maybe want to use something else. So click on probability, include all, press execute. Yeah. Press save. Yeah. Open up that file now. So if you look at the extreme bottom, what does it show? No, not here, not here. No, not here, not here. Right. Go to the evaluate tab. Yeah, there. Now open up this file. Scroll to the extreme right hand side. What do you see over here?
There's a probability of
So,
regression model.
so your Rattle or you've used R to generate the probability score automatically, right? Right? So you've saved your model and you've used that model to score off another file, right? Now the only thing that you need to make sure is that the variable names and the order has to be in the exact same format in which it was on the training file, right, Siddharth? Yes, Siddharth, are you
Yes,
there?
Karan.
So if the variable names are changed or their order is changed, then this will not score automatically. Then it will give an error.
Yes. Yes.
Right? So the file format and the file logical structure has to remain exactly the same. Got it? So
Yes.
even if you are ignoring variables in your model building, right, they still need to be there in the validation file as well or any other file that you want to create. Right? Go back to Rattle and say I want to score off the training dataset and save it also. So how will you do it? You want to generate the scores for the training dataset as well. No. Cancel this. Cancel. Go to evaluate. Instead of this, you can save the training file. Click on training. Yes, go training. Execute. Now it will score off the training dataset and save it as a file as well somewhere.
Okay.
All right. So supposing you want to run multiple models, can you go to the model tab? Yeah, click on all models over there. Press execute. Press yes. Press yes. Alright, now go to evaluate and generate the ROC for all of the models on the training dataset. Right? What you'll see is that you'll get extremely large ROCs for the two models, which is your ADA and random forest, because on that you get a massive overfit as it is. Right? You get a massive overfit. But I want to validate the ROCs on a different file. Can you generate the ROC on validation dataset? Go to Rattle again. Right? So click on, instead of training, say I want to go back to evaluate. Don't go to data tab once you now click on CSV. So you're going to load a different file outside and generate the ROC based on that. Right? So this file should also have your actual variable configuration, right? Press open. That's it.
Validation or validation score?
No, validation, right? So it will now, so what it's doing is instead of, creating a validation data set from the original file, original data set that you've loaded, I'm going to validate it on an outside file. All right. Press execute. Right. Now look at the area under the curve and tell me which model is performing best. So which models are performing best?
GLM.
Logistic and RF, right?
Yeah.
Right. Suppose I want to score up only these two. Go to score option now. Score. Right. And unclick everything except the logistic and random forest. Right. And score of that outside file again. I want to score of the validation file. Yeah. Instead of class, make it probability. Wait a minute. Instead of class, make it probability. Now press execute. And save it somewhere. Press save.
What is it? Training school.
You have to change the name. Whichever name you gave, it will use that. Alright, anyhow, open this training code, all that CSV.
Okay.
Wait. So it's coming scoring data set using GLM. Open R.
Say it again.
Just open R. The R window. There should be an error over there. Yeah, so there is an error over here. Permission denied. Is that file already open in Excel? Close it.
Yeah, it is open.
Close. Right, now do it again. Score and save it. Yeah, it's there. Press execute once more. Press execute once more. Yeah, give it any name. Yeah, that's fine. Validation 2 underscore score. Give it 2 or 3 number. Yeah. Desktop. Alright, it's been saved in my documents. Open it up. Open it from my documents. This is not the file, it's in my documents.
Oh.
Yeah. Scroll to the extreme right hand side. And you get the two scores now, both the scores.
Yeah.
Alright. So you get scores for both the random forest and for GLM. And you can take the average of them too. So you can do, the average of these two scores. You get a model which would be slightly better than both of them together. Right. So if you generate the ROC for these two models separately, not like that. So take average of for each row. No, Kiran.
Oh, sure.
Right. You will say one score which is equal to the average of both the scores. Right. So I'm taking the average. So RF says 0.04, GLM says 0.07, the average score says 0.05. Right. So this is known as the combo score or a combined score.
Okay. And then take the average of this?
No, that's it for each observation now.
That's it.
it.
Okay.
Right. You can generate the ROC for this score separately. Right. You've got SPSS?
No.
You don't?
No.
Okay. So you can save this
Not on
file
this
later and generate the ROC for RF, GLM and the combined score and see whether the combined score is actually slightly higher or not.
Okay.
Alright. Typically, if you combine two scores which with similar ROCs, the combined score is slightly higher than each of them.
Okay.
Alright. Now, Siddharth, any doubts, any queries on doing Rattle for clustering?
No, nothing for R, but Karan, can you do this random forest and all in SAS?
No, you can't do that. So random forest and all of these are typically the latest machine learning techniques. Even if you can do it, you won't be able to do it on this normal SaaS. You'll have to buy, advanced versions. So SaaS licenses, they can cost up to $100,000 a year, right? So even a base SaaS license, which you're actually training on now, costs anywhere up to $7,000 to $10,000 a year for renewal, and the first time installation can go up to $30,000 to $40,000.
Okay. But does this work in enterprise, right? Or these options are available in minor?
Now that will be available only in E-miner, not even on enterprise guide,
Okay.
right? But random forest is a very relatively new technique. So as far as as far as my knowledge goes, it has not been implemented by SAS as of now. Neural network is available, right?
Yeah.
Decision trees are available. I don't know. I don't think boosting is available yet, right? Support vector machines are available. Logistic is the bread and butter of the analytics industry, so it has been available since since ever SAS has started basically.
But isn't R better than SAS? I mean, it's free and you have all these techniques and a user interface.
Yeah, well, the argument is on both sides. So even I've written actually extensive blog post on R versus SAS, and it's like the normal argument. It's an argument which has no ending. So people keep arguing which is better, but typically depends on what your requirement is. For example, if for Kiran, if he's going to do some consulting assignments as a freelancer setting up his own company, so Kiran would prefer doing it on R rather than SAS for obvious reasons, right, Kiran?
Yeah.
And why would that be, Kiran?
I can't actually. How much will it cost me to get a license? Or rather, the company has it, that's good, but
If you actually, what happens is, if the companies which you pitch to, if you factor in the SaaS license cost, you're not going to get the project,
yeah,
right? Unless
unless they already have it.
unless the company says, you can use our license to build the project,
Yeah.
right? So typically to get billing at a reasonable price, you'll have to start using freeware in the beginning initially at least, right? When companies get very big, when license cost is a very small part of the overall delivery, in that case, they really don't care whether it's R or SaaS, and SaaS is much easier to use than R,
Yeah.
right? So for a bigger company, the shift would be towards SaaS because they can need to deploy lots of people very quickly, and it's easier to train them on SaaS. But smaller companies who would want to compete on high caliber people running at very small cost, so they would use they won't even buy Windows, they do it on Linux, and they would use MySQL rather than SQL Server because you can essentially do everything on these free software. All right, for actually for
I can show you the demo.
for smaller companies who are starting off in consulting, their biggest license cost is actually Microsoft Office than anything else. But at the end of the day, you still have to make a PPT, you still have to create Excel files, so you need Microsoft Office for that. And Office is also very expensive. Right? But still lots of companies will want to do it on SaaS, but depends on whether companies want the models or they want the codes or they just want to deploy the intelligence.
Yeah.
All right. So any consulting assignments you managed to get, Kiran? Working on it?
Yeah, I'm actually I'm trying to finish a financial model for a solar company here.
Oh, right. Wow. Doing a logistic on it or what?
No, just financial model. Just trying to help them tell the story through numbers and as to what it costs to install their system versus others.
Oh, all right.
It's not a model yet. But I'm waiting. I talked to another guy last week, and he wants some analytics done. So then I'll probably contact you. So look at this.
Oh yeah. Alright, so that's your box and whiskers plot.
Factor 1 and 3 clusters are comparing. And this shows the distribution of factor 1 values.
Yeah.
Okay, it's factor 2.
Yeah, so this can actually help you sell the story.
But then again, all of these shows us it's significant, right? And visually, it's not easy to just look at it and say,
Because
hey, yeah, it's
what you've done is you've done it on the factors. You have to do it on the original variables because factors are not inherently, you don't know so what these factors are. You've done the clustering on them, but you
okay.
might want to do it on the actual variables so that you can understand, what the average age is looking like from an interpretability
It's,
point of view. If you give that to the client, he or she will not be able to understand that.
yeah. Password is not found.
You've not copied. You've got only factor 1 to age. Go to proc cluster and use the copy age option. Go to proc cluster.
Here,
Yeah, copy age. After that, run it. And on proc tree again, copy factor 1 dash 8, then age. Introduce, no, introduce age as well. No, in the same copy statement.
in the var,
Yeah, copy, yeah. After factor 8, just give age.
oops, just copy and age.
Yeah, run it. So in the proc cluster, when we say copy, it will only copy that variable but not use it. And now, do the proc ANOVA. Or you can actually, merge the cluster classification back onto the original data as well.
Okay. That's nice.
Got it?
So how do you get that all versus the clusters?
That's, that's how R does it. So you won't get it immediately like that. Right? If you want to get
Mm,
you'll have to do the prox and whiskers separately for age alone without any break in it. Right? Anyhow, this is the ANOVA. So for me, I have probably were working on which version of Enterprise Guide have you installed? The default one, is it?
this is 4.2,
4.2. Let me check which one.
4.3.
4.3. Which one do I have? Mine is also 4.3. So I don't know. Maybe there's some option, default option, because it doesn't give me the box and whisker that like that. What you can also do is give means age option. Go back
Say
to
it
the
again.
program. Right. Give means age before the run. Before run, just write
Mean
means age.
age.
Before run,
Okay.
means right, means cluster actually, means cluster. So it will give you the mean of the variable by cluster. Remove age.
So I had this line for ODS graphics on.
Okay, maybe that's because I haven't been using that. So typically, base SAS doesn't have an ODS option. Yeah, scroll up. You should get the mean of each of. Scroll up. Yeah, scroll down below the graph. Is there something option below the graph as well?
Yeah.
Yeah. So you get the mean of all the 4 clusters as well. So I can see that cluster 4 is, super oldies in your clustering, right? So you've got a set of super oldies in cluster 4, and you've got fairly, comparatively young people in cluster 1. Cluster 2 and cluster 3 have a similar age profile.
Okay.
Alright, so that's an interesting result. Now you can
break down into 7 clusters, groups.
So you can, do this analysis using a few key variables and then, come up with a marketing plan for each of the clusters, what needs to be done. Right? And now the key is, even though cluster analysis, you can generate as many clusters as you want, but, anywhere between 3 to 7 clusters is typically the optimum number which a business person would be looking for. If it's less than 3 clusters, then you don't need to do segmentation. It's more than 7 or 8 clusters. It's just way too many groups to do your targeting on, right? So there's no point on doing a 15 cluster solution, because what are you going to do with 15 clusters?
Okay.
All right.
Yeah.
Okay. Any doubts? Any queries, Siddharth? Anything?
No, Karan.
Okay, so what I'm going to do is, probably during the week, so I'm just going to write out a mail, concluding this, and in this week I'm going to upload. So there are a few videos pending from my sites, which I've, actually created on my local system. So I'm going to update and upload those videos on YouTube and share it with your IDs, and then, send out an invitation for the wrap-up sessions next weekend. Right, so we'll probably have a couple of hours next weekend and do a quick recap of all the topics that we've covered today.
Okay.
So everything that we've covered today, starting from hypothesis testing all the way down to factor and cluster analysis. Prime sort 90% of it has been on SAS, but I think probably there's some steps which need to be also shown how to do on SPSS and Rattle. So this week, what I would suggest is, both of you can install SPSS as well, and try out everything from hypothesis testing to clustering to linear regression, logistic regression on SPSS. Try backward, forward, the Hosmer-Lamshaw test, as well as the factor analysis on that, and start collating your list of questions, doubts, queries, both from a practical point of view, that is how to do it, and the analytics point of view, to even if you have any doubts or questions regarding the statistical background.
Okay.
All right.
Yeah.
Okay. All right. So we'll meet up next weekend again.
Okay.
Okay. Excellent. Thank you.
All right. Thanks.
Pretty helpful.
Thank you. Bye.
All right. Thanks, Kiran. Thanks, Siddharth.
See you.
See you. Bye-bye. Yeah, Malik, we've got your file over here.
Okay.
So let's go through this. Siddharth, you managed to do the exercise? Hello, Siddharth.
Yeah, Karan, I didn't get time to do that.
All right. No problem. Try and exercise, do the exercises, else you'll start forgetting very soon. All right, so let's have a look. So yeah, Malik, can you take us through this? Is this your sheet?
Yeah.
This is your sheet, right?
Yes.
All right. So telecom.
No, this is not mine. No, this is not mine.
Okay, let me just close this.
Yeah. This is mine.
Okay, this is your sheet. All right. So this is your model on the original variables.
Yes, exactly.
All right. This is original variables. Training or validation? This is training or validation?
I think you are referring to other sheet right there.
Yeah.
This is Siddharth's sheet, I guess.
Okay, this is not your sheet. Is this your sheet? Wait a minute. I'll just open your mail itself.
Okay.
Look. All right, here's your mail. So. Yeah, so let's have a look at telecom factor training model, telecom factor validation. Right, so I'm opening your validation sheet over here, Malik. Let's have a look.
Okay.
Alright, yeah, so here you've validated the model. Right, cumulative goods you've got over here, cumulative bads you've got over here. And where is the separation? Right, here is the separation. So you're getting a
separation.
So you're getting a KS separation of 43 on validation, right?
Yes.
And first decide.
In the case of variables.
Pardon?
In the case of variables, that is a model built on the variables, KS separation is both for the training model and validation model.
Okay. Alright, let's have a look. So this is your validation model for factors. Are you sure? Yeah, this is for factors. Okay. And your KS was 43.
This is not for factors. This is on the variables.
So this is written telecom factor validation mod underscore F.
Yeah.
So this is the full variable model or the factor model?
This is the variable model. One more Excel sheet is there for a factor model.
Let me have a look. Alright, the other sheet's name is telecom factor valid mod F.
There are 4 sheets.
The names are the same.
Mod F, yeah, that is a factor model.
Okay, let's have a look.
No, mod F.
Yeah. So here your KS is 46 for factor model, you're saying. Alright, and for the training model, it's 43 for the variable model. So which one is performing better? So factors is performing better for you? Yeah, Malik? Malik?
Karan, you there?
Yes. Which model is performing better? Yeah, Malik, can you hear me?
Karan?
Yeah, Siddharth, can you hear me? Hello? Hello? Yeah, Malik, can you hear me now? Yeah, Malik, Siddharth, am I audible? Yeah, Malik, Siddharth, am I audible now? Hello?
Yes, Karan. Now you are audible.
Okay, perfect. So I was asking that which particular model is performing better for you, full variable model
Karan.
or validation model, or sorry, factor model?
Okay.
Yeah, so which model is performing better? All variable or factors only?
Full variable is performing better, but full variable validation model is.
So you're saying, no, Malik, I see your factors is performing better, right?
All variable.
No, your factors model is giving you better case.
Yeah, that is 46, right?
Yeah, so why will you say that full variable model is performing
with
better?
respect to ROC, full variable model is performing better, sir.
ROC on training or validation?
Because of ROC value. In the case of validation,
Malik, you calculated ROC on
around
training or validation?
852. Yes, sir. I have included ROC value in the mail itself, sir.
Malik, have you calculated ROC on training or validation?
Yes. Both, sir.
How did you do it for? So what is your ROC on validation factors and what is your ROC on validation full variables?
Validation full variable is 0.852.
That's training or validation,
And factor
Malik?
is 0.824.
Training or validation, Malik?
Validation, sir.
How have you calculated validation ROC?
Validation.
How have you calculated validation ROC?
I generated using SAS output itself.
But SAS output will give you training ROC alone, not validation.
No, I can.
Right, Malik?
Yes, I guess.
Malik, that proc logistic output.
Actually, I changed the data set to a validation set, and then arrived at
That proc logistic you run on training.
Yes.
So that is the training ROC, not the validation ROC, right?
Yes.
Right. So what I'm going to do is I'm going to paste this into
exactly.
SPSS.
Actually, I changed the data set.
Pardon?
Okay.
Yeah, Malik,
I did a mistake.
Explain to me what have you done. So there is some confusion.
Actually, generally we build a model using training data set, right?
Yes.
And we get the ROC value for the training data set.
Yeah,
so
but
similarly, I did the proc logistic model on the validation data set also. That means directly I plugged in the validation data set.
No.
And in the SAS output, I got the, that's what I did mistaking that, which is not supposed.
So Malik, you created two different models, one for training data set and one for validation data set, is it?
Yes.
But that's not what you're supposed to do, Malik.
No, only for ROC I did that. For calculating, only for calculating ROC value I did like that, and rest of things remain same.
For ROC, you can go to SPSS and generate the ROC, right?
Yes.
Right, I go over here and I get the ROC value out. Right, so I've just copied your data set, your actual variable and the predicted variable. So your ROC is coming 0.805 over here. Right? And this is on your validation lifts factor model. Let's have a look at your validation or your full model.
Validation with factor is coming to 0.785.
Right? Let's look at your full variable model. If I look over here, right? So Malik, your factor validation ROC is 0.805 and your full variable model ROC is 0.798,
Yeah.
right? So your factor model is slightly
Yes,
higher,
yes, sir.
very
Yeah.
little, by a very small amount. Got it?
Yes, sir.
Right? You can actually copy paste and put them into
Yeah.
your Excel sheets. You can generate the ROC and paste it over here
Okay.
and see what it looks like.
Okay.
Right? So 0.805 and 0.798. So
Yeah.
almost the same, but your factored model is slightly better. Got it? All right. All right. So Malik, be a little careful when you're doing this. Yeah, Siddharth, you have a question?
Yes, Karan. Karan, how can we generate the ROC curve and the area under the curve for a validation data set in SAS?
In SAS, there is a code to do it. There's a proc SQL code to do it. Remind me to mail it across. I'm sorry, I forgot to send it across. Right? So there is actually a
Okay.
proc SQL code. How it actually calculates is, I'll just open the whiteboard. No, there is a method. So have you heard of a method called the trapezoid method?
No, I haven't.
Right, so it's a mathematical method of finding
Okay.
out the area of any quadrilateral. Right, so typically, you know
Okay.
what your ROCs are looking like. Right, supposing this is sensitivity, this is specificity, right, and this is the diagonal line,
Random.
right, and I want to generate the area under the curve like this, right? So typically we are talking about this whole area. Right, so Siddharth,
Yes, Karan.
right, when we're talking about area under the curve, we're talking about this full area, all right? So this is the full area that we are
Yeah.
talking about. So this is the area under the curve that we need to figure out, right? We already know that this area is about 0.5, which is under the line. Just what is this part over the line that we want to figure out, right? Right, so how the trapezoid method works is,
Yeah.
right, so it takes up one of this point like this, right? So can I say that this point over
Yeah.
here is like this and it is like this point, right?
Yeah.
Right, then I have
Yeah.
another triangle which goes something like this, right?
Yeah.
Then I have another triangle which goes like this, right? So I have multiple triangles going like this, so I can keep calculating the area of these triangles, right, and integrate them over. So this becomes the trapezoid method, right? So I have these multiple triangles. What I do is I simply join these edges together. So I can join this edge with this edge, right? I can join this edge with this
Yep.
edge, right? So at the end of the day, what
Yep.
I will have is, instead of a curve, right, I will have what is a simply something like a quadrilateral with large number of edges. It will go like this, then it will go like this, then it will go like this, then it will go like this. So it will have edges over here. All right,
Yep.
I'll try to make it a little better.
Yep.
So it will go something like this, then something like this, then something like this, right? And this is my random line over here. So okay, I can always calculate the area of a quadrilateral, right? Right,
Yep.
Siddharth?
Yep.
So typically with this is how the area under the curve is being calculated, and there is a code in SAS which I'll forward to you that will implement this trapezoidal formula and calculate the area under the curve. All right.
Yep.
So we can calculate the area under the curve for validation data set as
Yep.
well. Okay. All right.
Yes, sir.
Now, so I see only Siddharth. Sorry, Siddharth. Only Malik has done the exercise. So I'm assuming Siddharth, you don't have any problems. But when you do it and try it, if you have any problems, you'll just have to mail it across to me. All right.
Okay. I'll do that. Yeah.
Right. So try it out. We'll move on to the next topic, which is your cluster analysis. All right. So can somebody explain what is cluster analysis? Anybody?
I guess it's breaking the population down into clusters with similar their demographic factors, or just grouping them on basis of.
Yeah, so it is also known as a subjective segmentation technique, right? So this is known as subjective segmentation. I am going to segment for the observation into what kind of groups? Yeah, you were right, Siddharth. So can you elaborate a little more?
It can be anything like similar demographic factors or psychographic factors. Just grouping them on a basis of certain similarities.
Similar behavior.
All right. So let's get a few definitions in, right? First of all, it's a segmenting technique, segmentation technique, right? So this is segmentation of the data set, right?
Okay.
All right. And this is segmenting the data set based on what? So how are we segmenting this data set? Yes, Siddharth?
So typically, I think.
How do you segment a data set? Based on what?
Suppose take the demographic state.
So it is based on the variables. Alright, so we are segmenting based on variables, right? For example, I've got two variables, age and height, right? Let's say I've got age over here, right? And I've got height over the y-axis, right? So can I represent my whole data set as a scatter diagram on the xy plane, Siddharth?
Yes, Karan, we can.
Right? So supposing, I generate this scatter diagram, it comes out something like this. Right? Then I've got some observations over here, right? And then some observations which are something like this over here, right? So now every observation has got a height and a weight, right? So typically how I represent is that this becomes the age and this is the height of that particular axis observation, let's say the age is x and height is y, right? Then this point with the coordinates x, y is plotted on the diagram or the scatter diagram, right, Siddharth? Right, Malik?
Yes, sir.
Right? So let's say age could be, 15 years and height could be like, 120 centimeters, right? And I have now plotted it on the XY diagram. Similarly, I plotted all the other observations that I have in my data set. Now, what is the objective of clustering? Right?
To group these kind of points which are very close to each other.
Group similar observations.
The dot in the graph
Right?
here.
So the objective is, right? The objective is to group similar observations in the same cluster.
Yeah.
Second is group dissimilar observations in separate clusters. All right. All right. This can also be summed up in the sentence, right? Homogeneity within clusters and heterogeneity between clusters. All right. What does this statement mean? So Malik, what does this statement mean? When I say homogeneity within
That
clusters
is similarity within the
and heterogeneity
that
between
is
clusters,
similarity within the group.
right? That means observations in the same cluster should be
That is
similar to each other,
yes,
right? And observations in different clusters should be
and
different with each other, right?
yeah,
Right? So Siddharth, I need to divide all of these
yeah.
observations into buckets such that observations in the same bucket are similar to each other and observations in the different buckets are dissimilar to each other.
Yeah.
Got it? Right?
Yeah.
So typically I can say, this is one underlying cluster in the data set. This is another cluster in the data set. This is the third cluster in the data set, and this might be the fourth underlying cluster in the data set. Right? So all of these clusters are separate from each other, right? They are very different from each other, but within the cluster, the observations are similar, right?
Yeah.
Right? And how do you define whether an observation is similar or whether the observation is different from each other? How do I say that? Let's say I've got observation A over here, I've got, let's say, observation B over here, and I've got, say, observation C over here, right?
Yeah.
Got it, Siddharth? So Malik, my question is,
Yeah.
which pair of these observations are most similar to each other?
A and B.
Why A and B? Why not A and C or B and C?
Suppose for any marginal increment in x-axis, it is in parallel with the marginal increment in the y-axis also, in the case of A and B.
What you are doing is, for example, I'll give you an option, right? These three sets of observations, A, B, and C, right? In A, the height is, let's say, I give height equal to 120 centimeters, and let's say, instead of age, I'm giving weight over here, right? So I'm plotting, Malik, so I'm plotting instead of age, I'm plotting the weight of the individuals over here.
Okay.
Right? So weight is, let's say, 40 kgs. Right? Now for B, B, let's say height is again 130 centimeters and weight is, let's say,
Okay.
45 kgs.
Yeah.
Right? Now for C,
Yeah.
height is 125 centimeters and let's say weight is
Yeah.
60 kg.
Okay. Yeah.
Right? So if I have these three observations, right, how do I figure out which observation is the closest to each other, which pair is
Yeah.
closest to each other, Malik? Right? So what we do is we plot them
Like
on
we
the
can have
XY,
the
so
ratios.
not ratios, right? What we do is we plot them on the XY graph, let's say weight is one axis, height is one axis, and then we simply take the distance between the
Okay.
observations, right? So I take this distance between the observations,
Okay.
right? And the distance between the
Mm.
smallest pair, the smallest distance between the pair is used to figure out which observations are closer to each other and which observations are further from each other, right?
Yeah.
So Siddharth, the closer two points are each other in the plane or in the dimensional space, the more similar are those observations considered to be. Got it?
Yes. Yes.
All right. So Siddharth, I have a question.
Yeah. Current.
Yeah.
Yeah, go ahead, Malik.
Yeah. Here, like we our metric is the distance between the variables, right?
Distance between observations, not variables.
Sorry, observation. So, if that is convert, what will be that distance in statistical terms, statistical parameters?
Correct. So I'm coming to that. How do you calculate distance between observations? Is that what you're asking?
Yes, yes. And also co- correlation with the statistical parameters that we came across.
Yes.
Yeah.
Let's say I've got 2 points A and
Yeah.
B, right? How do I calculate the distance between A and
Yeah.
B?
Yeah.
Right? Let's say the coordinates
Yeah.
of A and B are x1 and y1. B is x2 and
Mm.
y2. Right?
Okay.
Right, Siddharth, Malik, got it? Right?
Yes, sir.
Now the question
Yeah.
arises, how do I take the
Mm.
distance between A and B, right?
Yeah.
Yeah.
Alright? So let's say if I
We
plot
generally
this
have the
particular
distance
point,
from.
right? So let's say
Yeah.
Siddharth, I plot this particular point, right? So this
Yeah.
is x1 and this is the value y1,
Yeah.
right?
Yeah.
Similarly, this is x2 over here and this is y2 over here. So let me just make that clear,
Yeah.
right? So if I write it over here, so this is x1 over here, this is x2 on the graph, this is y1 over here, and this
Yeah.
is y2 on the graph, right?
Yeah.
Right? So now can I say that the distance between A and B is actually the hypotenuse of this right angle triangle?
Yeah. We can.
Right? Right, Siddharth? So this, sorry. So,
Yes.
so Siddharth, this is the hypotenuse, right? This is the base, this is the perpendicular,
Yeah.
right? So what is
Yeah.
hypotenuse equal to?
H square is equal to B square plus B square.
Right? Which formula are we applying over here?
Hypotenuse theorem.
Pythagoras.
We are applying the Pythagoras
Oh,
theorem,
sorry. Yeah. Pythagoras theorem.
right? So I'm not going
Yeah.
to ask you to derive the Pythagoras theorem over here, but you can do it using trigonometry as well, right? So I
Yeah.
know that h, right, that h is equal to p square plus b square under the root Right, Siddharth?
Yes, Karan.
Right? So can I say P is simply this distance?
Yep.
Right?
Y2 minus
And
Y1.
base is this distance? Right? So this is base
Yeah.
and this is the perpendicular. So what is perpendicular equal to? Enter in the formula, what is perpendicular equal to now? This is y2 minus y1, right?
Y2 minus.
Right? So
Yeah.
I can write y2 minus y1 whole square plus, what
X2
is v?
minus X in the
V is x2 minus x1 whole square under the root. Right? So if I've got 2 points x1, y1 and x2, y2, what is the distance between the 2 points?
Y2 minus Y1 plus X2 minus X1 the whole square.
No,
Oh, sorry,
y2
square
minus
of both
y1
and
separately
the
whole
under.
squared. So y2 minus 1 separately whole squared plus x2 minus x1 separately whole squared and then the under root. Got it?
Yeah, yeah.
Right? Not the whole square because that will be wrong. Right? So it is y2 minus y1 the whole square plus x2 minus x1 the whole square and then I take the full under root. Right? So is everybody clear how the distance
Yeah.
formula is being calculated?
Yes.
Yes, sir.
Right? So this is how we calculate the distance between points. Therefore, I can now start calculating the distance between any two points and based on the distances between the points, classify points which are close to each other into the same cluster. Right, Siddharth?
Yes.
Yeah.
Right? And classify observations which
Yes,
are
Karan.
very far from each other into different clusters then. So the closer the 2 points are, they get classified into the same cluster. The further away 2 points are, they get classified into separate clusters. Alright? So is the basis of clustering
Yeah.
clear? Right? So what kind of variables can be used for clustering?
Continuous variable.
So Malik, why only continuous variables?
I think in the rest of the cases, I think the distance is fixed, like categorical or ordinal statement as equal distance.
So Malik, I am using
On observation.
Malik,
Yeah.
I am using addition, subtraction, and multiplication, division in the formula over here, right?
Yeah.
Right. So Malik, this involves
Yeah.
subtraction and then multiplication, right?
Yeah.
So what kind of variables can I do subtraction, addition, multiplication, division on?
Continuous.
Right? Can I? So if I have a categoric variable like let's say I've got age, then I've got height, and then I've got let's say something like the shirt color, right? So
Okay.
can I plot shirt color on an axis?
No.
I can plot age and height, but I can't plot red and green because then the formula will become somewhere red minus green whole square, right? Plus the delta of age whole square plus the delta of height whole square, right, under the root. But I can't do this. This will create problems for
Yeah.
me, right? So that is why
Yes,
what kind of
exactly.
variables can be used?
Continuous. That is ratio variables.
Right? Only continuous ratio variables should be used, right? So typically it is similar to like factor analysis. Factor analysis also restricted to, right, your continuous variables. So answer is again ratio.
Ratio. Even interval also not, right?
Even
They won't
interval
have
we
the,
try to
they will be having
avoid.
arbitrary.
You can use, but we try to avoid that, right?
Okay.
So you're right. Ratio interval variables can be used. right? So I'll write ratio interval continuous variables only, right? Which can be plotted on an axis. Alright. So I have a question now. Let's say supposing this is the scatter diagram that I have, right, in my data set, right? So how many naturally occurring clusters are there in this data set, Malik?
3, correct.
3, right? Now to find out the distance between the observations, let's say I have 100 observations over here in my data set, right? To do clustering, I need to calculate the distance between every observation,
Yes.
right? So I will calculate the distance between every observation with every other observation and then classify the one closest to each other into the same cluster, and different observations observations which are very far away from into different clusters, right?
Yes.
Right? So Malik, if I have 100 observations, how many distances will I calculate?
Okay.
So how many pairs are there?
100 into 99. 100 into 99.
100 into
99.
that's it. It will be NC2, right? Right?
By 2
By
divided
2.
by 2.
Right? For example, let's say I've got 1, 2, 3, 4, 5 observations like this. So how many pairs are possible?
Yeah, it's selection of any 2 distinct points, that is NC2.
Right? Supposing I've just got 4 pairs, right?
Yeah.
So I'll make it easier. I've got 4 points. Right? Right? So Malik, I've got 4 points. 1, 2, 3, 4. So how many possible pairs are there? So this is one pair, second pair, third pair, fourth pair, fifth pair, sixth pair.
Yeah.
Right? 4 points give me 6 pairs. Right? How many pairs will 5 points give you? So I've got 1, 2, 3, 4, 5, 6, 7. Right? Then I've got 8, 9, and 10. Right? Now any other pair? Right? So 5 is giving me 10. So what is the formula? It is always n into n minus
N
1
into n minus 1 by 2.
by 2, right? Where n is the number of observations.
Right.
Right? So if I've got 100 observations, I need to calculate NC2 or n into n minus 1 divided by 2 pairs, right? Right, Malik? Now supposing you want to segment the customer database of a bank.
Yes, correct.
Right? So I want to segment the customer database of a bank. So a bank will have how many subscribers or customers?
Some lakhs.
How many lakhs? Siddharth, give me an example. How big will be the customer database of a bank?
Customer, it can be any figure, it can be 100 lakhs, 10 lakhs.
For example, take SBI, it's around 50% of Indian population.
Can I say, let's say 1 million observations?
Yeah.
Yeah.
Right? I want to segment 1 million observations. So this is, let's say, 10 to the power 6.
Yeah.
Right?
Yep.
Right? So Siddharth, how many pairs will I now create?
1 million into 1 million minus 1 by 2.
Can I say it is 1 million into 1 million itself?
Yeah.
Yeah.
Right? Divided by 2, so this becomes, let's say 0.5
10 power 9.
into 10 to the power 12.
So 1 million. That is 1 billion.
Right, Siddharth? So can I just say this is approximately equal to 10 to the power 12 only, right? So it's 10 to the power 11 or 10 to the power 12, which is a very big number, Siddharth, right? So how long will a computer take
Yeah.
to calculate 10 to the power 12 distances?
I'll take a
So how long will this take to a normal computer? How long will this take?
I think 5 to 6 seconds.
5, 6, 7 seconds, is it? A few seconds?
Yeah.
Okay, so tell me, Siddharth, a normal, computer, let's say a normal PC or a laptop that you have, in 1 second, how many pairs will that laptop be able to calculate?
How many pairs?
So tell me,
1/6 of this.
in 1 second, how many
Yeah.
pairs will this? So typically, how many operations can a laptop or a computer perform in 1 second?
That is
Megaflop, teraflop, petaflop,
that
right?
is limited to
Right? Supercomputers operate in megaflops and
limited to
teraflops,
processor.
right? So how many calculations will a
Yeah.
computer do in 1 second? Malik, how much? How much? 100,000 pairs, 10,000 pairs, 1 million pairs, 1 million
Yeah.
distances, right?
That is
Each distance requires,
instructions per second are
right? So Siddharth, each instruction requires squaring the distance and then taking the square root,
Yeah.
right? So every
Yes.
pair, every time I calculate the distance between, let's say, pair A and B, I need to first square two distances, square the delta x, square the delta y, add it up, and then take the under root, right? So I have to perform,
Yes.
right, 1, 2, 3 addition operations,
5
two
operations.
multiplication operations, that is
Yes.
squaring, and 1 under root operation,
Yeah.
Yeah.
right? So
Yes.
3, 4, 5, 6 operations for each pair, right? So let's say that every pair is equivalent to one operation itself, so we'll keep it as one operation, we'll just ignore this. So how many operations can a computer perform in 1 second?
Okay.
Give a figure, right? Let's say your computer is,
10
let's say,
operations.
1.5 gigahertz, right? Right, Siddharth?
Yeah.
Right, 1.5 gigahertz, 2 gigahertz computers are normal, right? How much is a giga?
Yes.
Yeah.
How much is a giga? 10 to the power 9, right?
It is 1024.
Right?
Yeah.
Mega is, 10 to the power 3, so giga is 10 to the power 6,
Yeah. Yeah.
right?
10 to the power.
10 to the power 6. So let's say it can do 10 to the power 6 calculations a second, right? Even though in actuality it will be more than that because there are 5, 6 operations per distance, but we'll assume in 1 second it can calculate 10 to the power 6 distances. All right?
Yeah.
Right? So how many seconds will it take to calculate 10 to the power 12 distances?
10 to the power 6.
Yeah,
10 to the power 6 seconds.
divided by 10 to the power 6. These many seconds, right?
Yeah.
Time for
That is 10 power 6
10 to the
seconds.
power 12 calculations is equal to 10 to the power 12 divided by 10 to the power 6. Right, Siddharth?
Yeah.
If
Yes, Karan.
अगर 1 second में 10 to the power 6 करता है, let's say for example in 1 second can do 10 to the power 6 calculations, right? To calculate 10 to the power 12 distances, it will take 10 to the power 12 divided by 10 to the power 6, right? How much is this, Malik? How many seconds?
10 to 6.
10 to the power 6 seconds, right?
10 to
Yep.
6 seconds.
How many minutes is this? 10 to the power 6 divided by 60 minutes, right? We assume this becomes equal to, let's say, 10 to the power 5 minutes, right? Assuming that 100 minutes make 100 seconds make 1 hour. To make our calculation easier, right? We'll take this as to be equal to 10 to the power 5 minutes. How many hours is this?
Divide by 60.
Sorry, 10 to the power 6, if I divide by 100, it becomes 10 to the power 4 minutes, right? So it becomes 10 to the power 4 minutes. And I divide by 100 again to get the hours, so it becomes 10 to the power 2 hours. So how many hours is that? 100 hours. 100 hours plus, Siddharth. So it will not take a few seconds, right? It will take anywhere from 100 to, let's say, 400 hours, even if we have a 1:4 ratio somewhere, to calculate the distances between just 1 million data set, right? So this is talking about, let's say, more than 4 days of calculation. Right, Siddharth? Right, Malik?
Yes, sir.
So, Malik, do you understand how difficult it is to calculate the distance between every possible point in the data set?
Yeah, it seems it requires a lot of computing power.
Right? So it will require a lot of computing power. So that's why we don't use this approach. We use something known as a heuristic approach. What is a heuristic approach?
Yeah.
Right? A heuristic approach is a shortcut approach.
Basically, heuristic means yeah.
A shortcut, right? So we won't calculate every possible. We'll only calculate a few. All right. So I'll just delete this off. Right? Amongst the heuristic approach, one of the most commonly used approaches for clustering is known as the k-means clustering. Right? Siddharth, have you heard of this term, k-means cluster?
No, I haven't.
Right? K-means. Malik, have you heard of this k-means clustering?
Yeah.
How does this work?
No current.
All right. So the K stands for how many clusters do I want to calculate. So when I want to do k-means clustering, I have to first give the value of k equal to some number, right? So in this data set, Siddharth, how many clusters do you want to create? Yeah, Siddharth, how many clusters do you want to create in this data set? Hello?
8.
Yeah, Siddharth.
10 clusters.
How many? How many clusters do you want to create in this data
10
set?
clusters.
8 or 9 clusters? Why 8 or 9, right? Siddharth, I see 3 naturally occurring clusters. Why not 3 clusters?
Oh, I was looking to the other data set. Yeah, 3 clusters.
Right? Supposing I want to create 3 clusters, what it will do is, it will, right, randomly assign 3 cluster centroids in the data set somewhere like this. Alright? Right? So these points are called the centroids. Right? In the next step, what it will do is it will calculate the distance of every observation with these centroids. Right? So I calculate the distance of every observation with these centroids. So if I have n observations, how many calculations am I doing?
Yeah.
Yeah, Siddharth, how many observations am I doing? How many calculations am I doing? When I calculate the distance of every observation with these 3 centroids, so how many observations or how many calculations am I doing?
There'll be n into number of points. K into n
it be 3n calculations, Siddharth?
And
Where k equal to 3?
oh yeah.
Or can I say
Yeah.
kn, kn calculations? In this particular case, if I'm working with 10 to the power 6 observations and I want to create 3 segments, then how many calculations is that?
K into 10 to the power.
So it becomes 3 into 10 to the power 6 calculations.
Yes.
Right? So after this, what will I do now? Once I've done these calculations, what's the next step?
Next step is
I assign every
we
observation.
have the points which have the minimum.
Yeah. So now I assign every observation to the centroid which is closest to it. Right? So all of these observations get assigned to this centroid. Right? All of these observations and a few of these observations get attached to this centroid. And all of these observations get attached to this centroid.
Yes.
Right? And I have my solution at hand. Right? Right, Siddharth?
Yes.
Right?
Yes,
So
correct.
this is known as the first iteration. But is this the best possible clustering solution? Or can I make it better?
We can go more steps.
So how do I do that?
Different centroid points.
Right? How do I get the second set of centroid points? Can I, for all of this cluster, calculate the average?
Should be a little.
Right? Can I calculate the next centroid as the average of these observations?
Yes.
Right? So instead of centroid being here, where will it go next? The next centroid
Somewhere in the middle.
will move somewhere over here. Right?
Yes.
It will move somewhere over here. This centroid will move over, it will go over here. And this centroid, instead of being here, it will move a little towards this point. Yeah?
Yes.
Right? Then what I do is I remove the previous cluster classification. I actually delete it. I don't need it anymore. Then I recalculate the distance of every observation with these new centroids now. I disregard everything. I repeat this whole process once more. Alright, Malik?
Okay.
Malik got it?
Yes, sir.
I repeat it once more.
Yeah.
Right? Then I reclassify every observation again to the centroid closest to it. Now what will happen is this particular observation which was going into this cluster will now start going into this cluster. Right? So this observation is actually closer to this centroid. Right, Siddharth? Because this centroid has become closer and this centroid has actually gone further away. So this point gets classified over here. Right, Siddharth?
Yes.
Right? So my new cluster definition will come something like this. This becomes one cluster, this becomes the second cluster, this becomes the third cluster. Right? And how many calculations will this take?
Same, K into N.
First iteration, second iteration will take again 3 into 10 to the power 6. Right? After this I can do a third iteration, a fourth iteration and a fifth iteration. Right? Till that time, after a certain while, I'll see that my centroids stop moving. They'll reach the center of the clusters, right?
Yes.
Right? So typically after, let's say 8 to 10 iterations, right? Centroids stop moving. So typically we do about 10 iterations in this, right? So if I do 10 iterations, the total number of calculations is 10 into 3 into 10 to the power 6,
Yeah.
right?
Yes.
So this becomes
30.
3 into 10
Yes.
to the power 7 calculations.
3 into 10 is the
And if in 1 second I do 10 to the power 6 calculations, so this will take 3 into 10 seconds. It will take about 30 seconds to do the clustering.
yes.
Right, Malik? Yeah,
Yes,
Malik,
sir.
got it?
Yes,
So if I do it
Yes,
the
sir, I
full
got it.
way, it will take me about
Hmm.
4
4 days.
to 8 days to do this clustering exercise if I do it with every observation and distance. And if I do it using k-means, it will take me 30 seconds.
Yeah.
Right? So,
Karan, I have a doubt here.
yeah, go ahead.
Yeah, we have identified centroids, right, at the first iteration.
Yeah, those centroids are identified randomly within the data distribution. So the centroids are not going to be identified, you know, x1, x2, and x3 over here. Then majority of your data is over here,
Okay.
right? So the centroids are identified
Yeah.
where the majority
Yeah.
of the data is lying, right? So
Okay,
looking
that is
at
a
the
random selection, right?
yeah, so looking at the observations, we randomly select a few points and make them the centroid,
Okay.
or looking at the variable distributions, right? So knowing that where is the maximum minimum of each variable, I know that maximum of this variable lies here, minimum lies here, minimum for this variable lies here, maximum lies over here. So this automatically gives me a square within which most of my observations lie, right? So I randomly pick up some
Okay.
points within the square and make them as the centroids. All right. The only disadvantage is that I have to specify this
Any
value of k. Before I even do the clustering, I need to specify how many clusters to create.
even that is also
Right? So we need to
what could be the
specify beforehand.
pre yeah. What could be the assumptions for specifying particular number of k?
Yeah, typically that is how many clusters we want.
What could be the basis?
Right? Typically we are always generating between 3 to let's say 7 clusters. Right? We rarely go more than 7 clusters, and below 3 there's no point. We might as well do high medium if I'm doing two observations or 2 clusters. Right? So typically the minimum number of clusters we extract is 3, and maximum 4, 5. In the extreme cases we can go up to 7 clusters. Right? So it depends on like factor analysis. Number of factors is dependent on you, so number of clusters is also dependent on you itself. Alright? So what's the minimum number of clusters we can go for?
Okay.
Siddharth, what's the minimum number
3.
of clusters? Theoretical minimum.
1.
Theoretical minimum is 1. All observations in one supercluster.
Yeah.
Right? What's the max number of clusters?
The number of data points.
Equal to n, where n is equal to number of observation. Every observation, or n is the number of unique observations. Right? Where every observation becomes a cluster of its own.
Yes.
Right? So the number of clusters can vary theoretically between 1 to n, but typically we vary between 3 to 7. Okay? Alright, so this was how we do k-means clustering. Right? Now what I'm going to do is I'm going to demonstrate this on SAS. Right? So my SAS code may not work right now. So what we'll do is, since the others are also not here, I think we'll stop the class short now and continue with this tomorrow's session so that everybody is here. Right? But what I want you to do is I want you to run this particular code. So I'm writing down the code over here. Right? The code will be proc fast class. Right? Proc fast class. Data equal to data set name. Right? I'm still not clear how to do this. Right?
You can put it in the chart window, Karan.
Yeah, just let me try it out here. So max clusters equal to x, where x is the number of clusters you want to extract or is the number of k. Out equal to dataset name, where you want to specify the clusters. After that, give the semicolon, then give the id variable, right? So give id as the id var, so which is your serial number variable. Then give var v1 v2 till vn and run. Right, I'll just put the code into the chat window. Right, so proc fast class data equal to, let's say, data set name, max clusters equal to, let's say, x, out equal to out data name, id equal to serial number, var v1 v2 vn, run. Right, so what I want you to do is I want you to try out this proc fast class code only on the telecom dataset independent variables. And needless to say, avoid the categoric variables in this data set. Right? Avoid all the categorical variables in this data set. It makes no sense to do it on categoric variables. So just like factor was done on the continuous variables, do this also on the continuous variables. And open the output data set and scroll to the extreme right hand side. You will see all observations get classified. Give x equal to 3 or 4 or 5, right, and compare the result. Alright, Siddharth, you will be able to try this exercise out.
Yeah, Karan.
Right. So what I'll do in tomorrow's class is I'll start with the proc fast class output in SAS itself. Right. One is doing this. In the next class, I will discuss the output. How do we interpret proc fast class? Got it? Right. And proc fast class is nothing but k-means. Right. So fast class. Sorry. Right. So fast class is your k-means procedure in SAS. Okay, so before we sign off, Siddharth, now are you clear what does k-means clustering mean?
Yes, I'm clear.
Yes, Siddharth, you are getting completely it's coming. I can't hear you. Can you try it again? Hello?
Yeah, Karan, I'm clear about this.
Alright, so k-means methodology you understand,
Yes, Karan,
right?
I'm clear about this.
Right? Malik, are you also clear?
Yes.
Yes, Karan.
Alright, so in tomorrow's class when everybody is else there, I'll do a quick recap. So tomorrow's class I'll ask you to explain k-means clustering, alright? Right, Malik?
Yes,
Sure.
sure.
Okay, right? Proc fast class
Yeah,
output, then I will explain tomorrow's class again. Okay, so Siddharth, try and send me the exercise also. The factor logistic exercise, Siddharth.
Yeah, I'll send it to you by tomorrow.
Alright, try and send it to me by tomorrow, the Charles Book Club. Alright? Okay, and tell me, on the credit case study, can we do the, can factor analysis be done on the credit case study at all?
No, as of now.
Yeah.
Yes, no.
No.
We can do it, but there are a lot of categorical variables in that.
Right, there are only 3 continuous variables, so we cannot do it.
Yeah.
Alright,
Yeah.
so it makes no sense to do factoring on all the categoric variables. That will be an incorrect use of factor analysis. Alright?
Yeah.
Okay, so let's reconvene tomorrow same time.
Karan,
Yeah, Malik, go.
yeah, I have a question, last question.
Yeah, go ahead, go ahead.
Yeah, see here, like we are considering like mean or distance is the criteria. Suppose take two variables, that is height and weight, as we took in the example.
Yeah.
So is it required to have the same unit or same scale of the variables that we are
Yes, so that
conducting
is
clustering?
what I will cover tomorrow. So we need to standardize variables as well,
Yeah.
right? So that is known as
One of
variable
prerequisite,
standardization.
I guess.
So that we still haven't covered yet.
Yeah.
You're right, because we are using the variance between the variables, right? Right? In
Yes,
some
yes,
variables, the let's say
yeah.
age is in years, but height is in centimeters,
Yeah.
right? So obviously
Centimeters, and
centimeters
the
will
scale even
contribute
range is
more
also
to the
different,
distance.
like distance.
Yeah, so distance gets biased by centimeters. If I change the height from centimeters to meters, right, then suddenly the impact of height is
Yeah.
removed from the distance formula,
Yes, exactly.
right? So we always standardize variables. So that is what we will cover tomorrow. All right?
Okay. Okay.
All right.
Yeah.
All right, guys. See you tomorrow.
Current tomorrow I may not be available.